Chapter 2 is on polynomial and rational functions. So 2.1 starts with quadratic functions, which are functions that are degree 2, which also make the shape of a parabola. There's two common formats for a quadratic function. This first one is vertex form. Your book also refers to this as standard form, and that's f of x equals a times x minus h squared plus k. This is a parabola. It's going right h and up k, so the vertex would be hk. General form according to your book is f of x equals ax squared plus bx plus c. And if you wanted, you could find the vertex hk by using h equals negative b over 2a and then plugging that value back in to evaluate for k. Okay, so for the first example, we're going to transform the given equation to standard form, find the intercepts, the axis of symmetry, and then sketch a good graph. Because it says to transform to standard form, remember your book thinks of standard form as vertex form, so I'm going to do this by completing the square. I know that many of you are more familiar with negative b over 2a, but completing the square is a valuable tool. Okay, so I have f of x equals x squared plus 8x plus 5. I want to complete the square so I can get it to look like the vertex slash standard form. So I want to complete the square for the x. So I have x squared plus 8x, and I want to complete the square, so I'm going to add something here to complete the square. I am going to keep the plus 5 at the end. So this is still the same equation as the one above. Now to complete the square, I look at the middle term. Half of 8 is 4, and then 4 squared is 16. Okay, now I just kind of randomly added 16 to that side of the equation. So to balance out the fact that I randomly added 16 to the equation, I need to subtract 16. Okay, 16 minus 16 is 0. So technically this equation is equivalent to the equation on the step above. Okay, but why did I do this? I did this so that now that the x squared plus 8x plus 16 could be factored into a perfect square, because x squared plus 8x plus 16 is factored into x plus 4 quantity squared. And then at the end I have 5 minus 16. 5 minus 16 is minus 11. Okay, so I have already transformed this to standard form or vertex form. Okay, from this, I already can determine that the vertex will be negative 4, negative 11, because this is the parabola shifting left 4 and down 11. Okay, the next thing I'll probably get are for the intercepts, I think I'll do the y-intercept first, because that's the easiest one to get. Remember, the y-intercept is always 0, comma something. So if you imagine you're plugging 0 in, I'm going to plug it in the original function because that would be easiest. If I put a 0 here and a 0 here, then what am I going to be left with? I'm just going to be left with a positive 5. So my y-intercept's just 0, 5, which happens to be the c value if it is in general form. Okay, next I'm going to find the x-intercepts. So to find the x-intercepts, I want to substitute a 0 in for y. I have two options. Actually, I have more than two options. I could plug the 0 in here, if that looks like it's easier to solve, or I could plug the 0 in here, if that step looks easier to solve. Because the original function does not look factorable, I think I'm going to plug it in the later step after I completed the square, because I can solve using square root. Okay, so if I have it like this, I can add the 11 to the other side. Okay, to cancel the squared, I'm going to square root. So I get plus or minus root 11 equals x plus 4. The squared triggered the plus or minus. And then if I minus the 4 to the other side, I'm going to write this the other way too. I get negative 4 plus or minus root 11. Okay, now these are representing the x-intercepts, so I should write these as ordered pairs. So this is negative 4 plus or minus root 11, comma 0, and that is two different points. That's negative 4 plus root 11, comma 0, and negative 4 minus root 11, comma 0. Okay, so I found the intercepts. Let me keep track. I have the vertex, I have the y-intercept. The axis of symmetry runs through the vertex, and it's vertical. And I think a lot of you use AOS for axis of symmetry. The axis of symmetry is a vertical line, x equals, and it passes through the vertex. Since the vertex is negative 4, comma 11, it passes through x equals negative 4. Okay, so I found all the information. I'm going to go ahead and sketch my graph now. And this is just going to be a sketch unless it tells me otherwise. Okay, as long as everything's kind of in the right place, I'm good enough on the sketch. Just label your points so I have an idea of what you're graphing. Okay, I'm going to graph the vertex first. I have no scale, so I'm just going to estimate. Let's see. -4, -11 should be somewhere in this quadrant. I am going to label it because I have such a terrible sketch. If this actually had a grid and I had counted the spaces, it wouldn't be necessary. Okay, let's see. I'm going to go ahead and sketch the axis of symmetry at x equals -4. Okay, what's next? I have a y-intercept at 0, 5. I'm just estimating 0, 5 maybe around here. I'm going to label it though because I did not draw this to scale. Okay, now the x-intercepts, I have two. One is -4 plus square root 11 and one is -4 minus square root 11. Now square root of 11 has got to be 3 point something because it's a little bit bigger than square root of 9. Okay, so -4 plus square root of 11 is really -4 plus 3 point something. So if I do -4 plus 3 point something, I get -0 point something. So this is somewhere around here. And as long as it's in a reasonable location, I'm fine with that estimate. So this is -4 plus square root 11 comma 0. And that lines up pretty well. Now if I do -4 minus square root 11, that's -4 minus 3 point something, which is -7 point something. So it's reasonable to guess that that's going to be around here. Okay, and if my parabola started to look crazy, I would know that I had made a mistake. Okay, I'm going to go ahead and graph the parabola now that I have all that information. Okay, and that's a good sketch. Since it was a sketch, I did label my points and made sure they were in the correct quadrant and reasonably placed. Okay, I'm going to follow the same directions for the next function. This is f of x equals 2x squared minus 12x plus 10, but the a value is not equal to 1, so it does make it a teeny, same process, but a little bit, you need to be a little more careful. I do want to transform this to standard or vertex form, so I want to complete the square. But in order to complete the square, I have to first factor out the 2 that is the coefficient of the x squared, because I don't want that to be there. X squared, now 2 times, this becomes 6x, and then I'm going to want to complete the square only on the expression inside the parentheses, which means I still have that random plus 10 way out at the end. Okay, this step is still equivalent to the previous step, because if I distribute, I still get 2x squared minus 12x. Okay, now I want to complete the square on the x squared minus 6x plus. Okay, so let's see. I think most of you learned to divide by 2 on the b term and then square it. So -6 divided by 2 is -3. -3 squared is 9. When we complete the square, we always add a positive. Okay, so now I've completed the square, but now the equation's out of balance because I added 9, which is not okay. Okay, now I did add 9, but this is in parentheses, so I technically added 2 times 9. So to counteract the balance that I added 2 times 9, I need to subtract 2 times 9. Okay, and then look at that and see that's still equivalent to the other equation because I added 2 times 9, but I subtracted 2 times 9. Okay, and then from here, I'm going to go ahead and factor that so that it will be in standard form. This is going to be x minus 3 squared. And then what is that? 10 minus 18 is minus 8. Okay, so now I'm in vertex form. Okay, and the great part of vertex form, of course, is that I can get the vertex. This goes to the right 3, down 8. So I've got the vertex. Okay, let's see. The y-intercept is another easy one to grab. Y-intercept is 0 something. 0 comma something. You can plug in the value 0, or because this is already in general form, I can just look at the c term. 0 comma 10 is my y-intercept. Now I'm going to get my x-intercepts, and just like last time, you have a choice of where you want to plug y equals 0 in. Okay, now you could plug it in here like I did last time and use square root to solve it. That'll work. Or I can plug it in the original equation and solve it there. Okay, I normally glance at the original equation because if I can factor it, I think it's faster to factor. But the square root method will always work. So if you prefer that, you're welcome to use that always as well. Okay, so let me see. Let me find the x-intercepts. Okay, I'm going to use the original equation. 2x squared minus 12x plus 10 equals 0. It looks like it might be a little tricky to factor, but there's a common factor. they all divide by 2, so I'm going to factor out the 2. Okay, then I can go ahead and factor this. Okay, multiplies to 5, adds up to -6, so it's got to be 5 times 1, and I got to have a minus and a minus, which means x equals 5 and x equals 1. So my x-intercepts are at 5, 0, and 1, 0. Okay, I'm going to go ahead and sketch a graph. Let me think about it before I draw it, because I just want to make sure I have the right quadrants. Okay, vertex is in quadrant, looks like 4. Okay, this is just a sketch. I'm going to label the points since I know that I'm just doing a sketch. So 3, -8 is, let's say it's out here somewhere. Okay, I'm going to label it so you know that it's out here. Okay, where's my y-intercept is 0, 10. So if that's 8, maybe 10's up here. I'll label it since I am not drawing very well to scale. Okay, my x-intercepts are at 1, 0 and 5, 0. If that's 3, -8, then 1, 0 is probably here. 5, 0 is probably here. Okay, and that's a decent graph, I think. Okay, it is opening up because A was positive and it has a stretch. It looks like I left off my axis of symmetry, so I'm going to sketch that in. And then I'm going to write it. So axis of symmetry was x equals, the vertex was 3, -8, so x is 3. And that's a good sketch. Okay, for example 3, I'm going to write the equation of a parabola or a quadratic function with a vertex of 1, 2, and it's going to be passing through 3, -6. Now, depending on the information it gives me, I might use vertex form or I might use general form. Because they're actually giving me the vertex, I'm going to use the vertex or standard form. Okay, I'm just going to copy that down to remind you. So that's a times x minus h squared plus k. Okay, because they already gave me the vertex, this is h, this is k, I could plug that in right away. X minus 1 squared plus 2. Okay, so the only constant I still need for this equation is the a value. How am I going to get the a value? I'm going to use the other ordered pair. Okay, this is my x, this is my y, and I'm going to use that to solve for a. Remember, y and f of x are the same, so -6 equals a times, and for x I'm going to plug in 3. Okay, what am I going to do? Can I do 2 steps at the same time? I won't because it's your notes. Okay, let's see. 3 minus 1 is 2. 2 squared is 4a. Okay, I'll minus the 2. Okay, what do I get? A equals -2. Okay, and then once I found that information, I'm going to go ahead and plug it in to get my final equation. A is -2, and then I already knew the rest of the equation because I was given the vertex. Okay, for the last example, I'm going to find the vertexes of f of x equals x squared plus 3x plus 5. If you like to complete the square, you're welcome to complete the square, but I know many of you like the -b/2a formula, so I'm going to go ahead and use that here. It doesn't tell me I have to transform it to standard form, so I'll use the formula here. So a is 1, b is 3, c is 5. According to the formula, if I want to find the h, it's going to be -b/2a. So h equals, what is b? b is 3, so -3/2 times a is 1. So h is -3/2, which is nice because now I know the vertex is going to be -3/2 comma something. Okay, how do I get this something? I plug it back into the original function to see what k is. So k equals, and I'm going to take the -3/2 and plug it in for x in the function because that'll give me the y coordinate of the vertex. So -3/2 squared plus 3 times -3/2 plus 5. That's 9/4 minus 9/2 plus 5. Let's do common denominators. 18/4 plus 20 over 4, 20 minus 8 is 2, 2 plus 9 is 11. So I get 11 over 4. And if they told me I could use a decimal, I would use a decimal. So the vertex is negative 3 over 2, 11, 4. And if I had completed this square, I would have gotten the same solution.